Okay, so again, hello everyone. Welcome to our webinar, Top 5 Cases in Multi-Utility with MaxBill Machine Learning Models. And let me introduce myself. My name is Kate Niechet. I am a content creator at MaxBill, the one who's making all our tech stuff, technical specifics into digestible and approachable for our dear clients and partners. And also I'll be moderating today's event. And also let me introduce our second speaker, who's Ronnie Rector, and our AI project manager. He will walk you through our innovative models. Okay, so now I know we have representatives from other countries. I know there are companies from Czechia, from United Kingdom, Italy, Israel, Indonesia, Iran, the Emirates. So guys, welcome, welcome. Okay, and also a little reminder that if you have questions during our event, please just do not hesitate to drop them in our chat. Okay, so yeah, top 5 cases in multi-utility with the MaxBill machine learning models. Before getting closer to our innovative models, let me say a few words about MaxBill and what we're doing here. So MaxBill solution is B2B SaaS solution designed to deliver CRM, billing, complex partner management, invoicing, and reconciliation. MaxBill multi-service delivery is on multiple product lines is currently used by dozens of companies supplying products and services in energy, utilities, telecommunications, connectivity, and gaming. So we've been in the field for 28 years now. I think that it's our bread, and bread and butter, proactive billing. We know ins and outs of it. So, and gladly provide efficient and powerful billing to our dear clients. We have the 5th generation of our product and almost around 75 implementations have been executed and fulfilled across Europe. Okay, so with who we work? Particularly in energy and utility, these are energy providers who work with traditional energy supply, renewables, distributed energy resources, electric vehicles, which is mainstream nowadays, so it was different business models. Speaking of multi-utilities, we provide our solutions to municipalities, city services, we provide tenant billing, public and independent utilities. Okay, so before getting closer to our models, let me outline the most, I would say, essential, the key challenges that we see utilities face nowadays. So first and foremost, it's the growth of customer debt that negatively affects the financial performance and financial ability of business. Only in the UK, the total debt, well, actually the statistics of 2023 estimates up to £3.6 billion. So really the sector indebtedness is huge. Okay, the next challenge is increased customer churn. We see huge customer attrition throughout organizations. Just a little reminder that attracting a new customer is 7 times more expensive than retaining an existing one. The third one is fraud and consumption anomalies that also negatively influence customer experience, company economics, and overall financial ability. High load on call centers as a consequence of increased individual costs and decreased customer loyalty. Regulatory compliance is also another challenge. It's like never changing, right? Because company has to navigate between regulatory compliance and customer support, while regulations always support and greenlight customer more. And last but not least, downgrade in rating and damaged reputation. For example, in UK, we know there are such watchdogs like Ofgem who keep an eye on customer experience with organizations, and we know this case when in 2023, two biggest energy suppliers were downgraded in ratings because they had their switch of customers very slow. Yeah, that's what the case. So, and today we're going to talk about like 5 machine learning models and algorithms. Let me name them. It's customer churn prediction model and revenue loss, customer debt prediction model, demand response patterns forecast, anomaly and fraud detection, visual CSR, and also we will decode what is it, what if simulation. So now I'm giving the mic to my dear colleague Ronnie. Ronnie.
Thank you, Katarina, and thank you everyone for joining in today. My name is Ronnie Rechter, AI Project Manager in MaxBill, and I will be guiding you through today's webinar. Indeed, we have 5 models that are based on machine learning. One of them even incorporates generative AI and a simulation, which we review a little bit later. Now, on a high level, a machine learning model, those are the models that are trained on historical data set, be able to find patterns, and give us some prediction on forecast so we can base our decision more fundamentally. Additionally to that, there is an extra bonus at the end after we review the models. Now, while preparing to this webinar, it reminded me of a story of a conversation I had with my friend. We were doing barbecue, and interestingly enough, the topic of internet package was brought up. Now, my friend asked me, how much gigabytes do I have a month? I told him I have 50 gigabytes a month as an internet package. He said he also had 50 gigabytes, but decided to downgrade to 10 gigabytes because it was too expensive, and he thought 10 gigabytes is enough for the daily use. A little bit after our conversation, I asked him if the 10 gigabytes was enough for him. And he told me that after he downgraded to 10 gigabytes, another internet service provider called him and offered him 50 gigabytes for a better price. So he took the deal, switched the company, and now he still have 50 gigabytes for a more attractive price. Now, I'd like you to think about it. Could the company which lost the customer, such as my friend, could do some actions to retain the customer? Could the company spot some sort of non-satisfied customer and offer him perhaps a discount and retain him? And this is exactly the main point of the first model I'm going to show you today, the customer churn prediction model. And the idea is to transition from reactive to proactive, meaning we don't want to see the customer take a step closer and closer to churning to another company. And then when he already churned to another company, take some action, but unfortunately it's too late. We want to be proactive, to spot exactly the action that leads to a high probability of churn, take action beforehand, and increase the retention percentage in the company. This is the model that designed to do such probability calculation based on determined parameters. We will find what parameters affect with the most high impact on the probability of customer going churn, and recommend what measures the company should take to actually retain the customer. How do we identify the contract with high churn probability? So this model is trained and based on a telecommunication operator that offers various services such as internet, TV, and mobile. We have an historical data set of 12 months, and we pass evaluation on 3 months. If you can see in the diagram, we have chunks. Each chunk represents 3 months on which we train the model, evaluate the model. After that, we have 1 month of a gap which ideally the company should take some action if the percentage is too high. And at the end of the month, we get the actual result of the model. I will explain a little bit further. A little bit about the model. This model is based on more than 50 parameters that affect the risk factor of future churn. Parameters, of course, can be expanded depending on each business unique requirement. Some example of parameters that were used to train the model. Contract type and payment method. For example, if the payment method is direct debit or prepaid. The average bill or invoice and debt in the past. Contract duration, whether the client is 1 year with the company or 5 years with the company. It can indicate on the level of loyalty of the customers and impact the probability of this customer churning to another company. Number of active services, whether the customer is using only telephony or uses TV, telephony, and internet. And the number of new services or removed services of a certain type. Let's take a look at a live scenario where we analyzed and found the customer with a probability of 73% chance of churning. In other words, if we do not take any action, a month from now, we will have a probability of 73% that this customer will leave this company, which is a very high percentage and should alert the company and advise to take some action. We have the data that influence this churn prediction. Let's take a look. So the internet tariff was changed twice for the last 6 months, indicating that something is not correct, whether it's too expensive, whether there is something wrong with the quality, or any other possibilities. The payment for services is made upon receipt on invoice, not through auto debit, meaning he first uses the services, then paying upon receiving an invoice. And the client terminated television services. Again, something is not satisfactory. Now, what the company should do in this situation? The system analyzed and concluded that the client use of internet service will reduce the probability of churn to only 20%, which is a very drastic change from most likely churning to only 20%. And we also have a retention scenarios, meaning what the company should do, what action to take. And here we find out that offering a discount for an annual subscription to internet service and not charging for access to social network through internet service will result in a reduced probability of churn. Now, I'd like you to imagine what if we could repeat this process among hundreds or thousands of customers. How will it affect the company revenue? It's a good point, and I think it might very drastically increase the retention rate. Let's take a look at another scenario which also includes, we call it what if scenario, meaning what should happen to affect the probability. So this model is trained, of course, on a data set of churned customers, and it makes it possible to build such scenarios. We have here an example of contract 580 that was active in the system with a probability churn of 53%. Yes, it's not very high, but it's not very low. It's a percentage where the company would like to take an action to be safe. And the most influential factor was that the customer switched to a cheaper tariff with a slower internet connection to minimize costs. Okay, now let's see what we can do with this information. We've simulated that the change of internet service to the basic tariff probability, basic tariff, will reduce the probability to only 6%. Meaning we took a customer that we can as well toss a coin and see if he's churning or not, to only 6%, meaning most likely this customer will not churn to another company and stay and use the services. And the potential scenario for this reduction is to change the tariff to basic plan while maintaining a faster internet connection. This is the first model of predicting the probability of customer going churn. Moving on, we have the second model, the model of contract debt risk. This model is designed to identify a contract with high probability going into debt. And we would like to use this model to reduce the bad debt impacting the revenue of the company. Here we will identify the most impactful parameters that affect this prediction, and a simulation. A little bit about this model. This model is based on more than 70 parameters that affect the risk factor of future debt. Of course, parameters and the amount of the parameters is unique to each business case. Some example of parameters. Again, we have here payment method, whether it's direct debit or postpaid. A significant surge in service consumption, meaning if a customer usually uses 7,000 kilowatts in this area of region, and suddenly the consumption raised to 40,000 kilowatts, this is a significant surge and might impact the probability of this customer going into debt. Customer region, where the customer is located, and again, contract duration. Looking at a life scenario, we have here a contract that has been using the company's services for more than 3 years. The system identified that the contract is a potential debtor of 90%. In other words, if we do not take any action, the model is trained in such a way that in a month from now, it provides us an inference that there is a 90% of this customer will have debt with this company. Now, the average contract bill for the last 3 months has significantly increased compared to other contracts in the service area. And this contract is using postpaid payment method. Then we simulate and see that the introduction of fixed payment would lead to a greater loyalty and reduce the risk of becoming debtor to only 5%. Would like you to pay attention to the numbers, that initially it was 90% and only introduction of payment method will reduce it to 5%. Again, imagine if this action could be repeated on a big segment of contracts, that taking an action on a chunk of big probability of going into debt will impact the revenue of the company. Another scenario, we had a contract with a probability of 51% of becoming a debtor. This is an average statistical contract of a customer who regularly pays bills, has average value consumption for a given region. With the help of forecasting system, we will determine what condition will cause this customer going into debt. And this is exactly the simulation we've been talking about. Now we are going to see what should happen to this customer going into the dangerous zone of going into debt. And here we noticed that the increase of consumption from almost 8,000 kilowatts to 40,000 kilowatts, the probability of becoming debtor is 73%. Now, what the company can do with such insight? For example, we can set some monitor to see if the customer is going above the regular consumption, and if it's indeed increasing the debt probability, we can take action before it actually happens. Okay, we take one step ahead. A little bit about the simulation itself, how we simulate and choose parameters to check how will it impact the final inference. So here we have the option to select manually what values we want to check to help us identify the most impactful one. So for example, as you can see here, of course, we choose the contract number on which we would like to run a simulation on. And we have the ability to manually pick values, to pick what would happen, for example, if the payment method would change from postpaid to direct debit, or what will happen if the consumption is not, for example, 8,000, it will be 40,000, for example. What will happen then? And so on, so on. The invoice, the tenure, tax exemption, etc. After we choose the values and the parameters we would like to check the simulation on, we receive the actual results. So we have the actual contract information above, the actual information and the current status of this contract. And on the graph below, we can see how the parameters that we chose impact the final probability or inference. And we can see that if we go to the right, we can see the parameters that increases the chances of this customer, for example, going debt or the probability of going churn. And values that take the graph to the left side actually decreases the chances. And this is how we can manually choose and see how the parameters and the value we chose impact the probabilities. Now, before moving on to the next three models, I would like to bring up a question. Does it always mean that if we introduce a fixed payment plan, is always a direct debit is the correct answer? Will always the direct debit reduce the chances of debt or churn? The answer is no, because for example, if a business offers a direct debit, which is a fixed payment plan, or a prepaid, the prepaid option will never go into debt because this customer will first pays, topping up a credit, and then uses the services. When he is out of credit, he's not able to use the services anymore. So in that case, the debt probability is 0. On the other hand, if a business offers a direct debit and a post-pay method, the direct debit generally will be a better option because a post-pay method, first the customer uses the services and then only pays. Moving on to the next models, we have here the demand response pattern forecast. This model utilizes historical data and current spending trends to estimate total consumption by region or business unit by date. A good use case for that model would be a large commercial building, for example, with high energy needs. Now, this demand response pattern forecast analyzes historical data and predicting the energy consumption patterns. This will help to optimize operation and reduce cost during peak hours and contribute to overall grid stability. And as a result, we have smart energy management and cost savings. The next model is Anomaly or fraud detection model. This model can indicate on a malfunction of a meter or a potential fraud by considering spending profiles from previous periods and similar customers. A good example for this model would be a house owner. For example, this house owner have a water leakage somewhere in the house. Now think about it. When this owner will actually know that he has water leakage? Probably at the end of the month when he receives a big invoice with a big amount, which will be surprising to the customer. Now, by using this model, we can already identify that the consumption is irregular and notify the customer beforehand, immediately, which of course will increase the satisfaction of this customer. And the last model, the virtual CSR. This is a chatbot based on generative AI, which is designed to understand the customer queries by asking several steering questions. This model also integrated with MaxBill through API calls and have the ability to perform a live action during the conversation. Basically, it should help reduce the workload on human CSRs and provide a better response to the end customer with his queries. And as promised, we are moving to the machine learning platform, which some of you may wonder, how do we train the models? How do we use the models in production? And especially if there are some technical people in the audience, I'm sure this will be even more exciting. So to make this all happen, the training model and using the models live, we have the machine learning platform. Okay, this platform consists of two main components: the model training camp and the model farm, designed to deploy model in production environment. This machine learning platform facilitates the entire model lifecycle, from data collection and analysis, model training, deployment in production, real-time operation, batch processing, and what-if simulations. The storage of model results data enables the preservation of historical information, allowing the assessment of model performance. A model that outperform will be returned to the training camp for adjustment and fine tuning. So we'll have a continuous improvement. Starting off with the first component, which is the training camp, where the model is initially trained. We can see that it all begins with a customer with a business case. Each customer wants to build his model for his requirements to provide specific inferences. This customer have a storage of historical data on which we will train the model. And the first component of the training camp will be the extract load transform. And this model is designed for handling incoming customer data, performing tasks such as addressing missing values, restructuring data to achieve a desired level of quality of the data, do categorization, rescaling, etc. And the first step in that case would be to establish the data flow, meaning importing the data from the customer storage to this component. We do this by establishing a reliable connection with the customer data storage via APIs and authentication tokens. After that, we proceed with data cleaning, when we take care of missing fields, fixing formats, and getting rid of repeated or identical entries, for example. Next, we do data restructuring. After we have a clean data, we organize it to a required level. So the next component, the training camp, can utilize this information, add in categories, and etc. And also we have a dashboard to visualize the primarily analysis. And this dashboard can also be used as a double check with the raw data of the customer and the process data. The next component of the training camp is the training camp itself, which is dedicated to train and store models for future management. Again, it utilizes the processed data from the extract load transfer model and proceed with training the models. Now, as you can see, we have here two virtual machines, one for baseline modeling and the second one for advanced modeling. I will elaborate a little bit on that. So the baseline modeling is the first step where we train the model based on the processed data. We evaluate fundamental machine learning algorithms and determine if some of the algorithms notably outperform random selection. After that, we are moving to elaborate modeling. And in this phase, we estimate the most optimal hyperparameter and model configuration to enhance performance. And we have at the end a dashboard to show modeling results. Imagine we have a lot of models. So this dashboard introduces the models and gathers metrics for each model performance to give comprehensive result for you. This is the training camp where the models are initially trained, or if already the model were in production and needs some adjustment, it returns to the training camp. Moving on to the machine learning platform. This is the infrastructure that is used in production. It might seem a little complicated, but it's really not. I will guide you through this architecture and see how it works. So we have here the central component, which is the model inference on the left. This component contains the actual interface, which connects to a variety of deployed model and offers the user the ability to select filters and to select jobs on which we would like to get inference. Of course, user can request any model and result from any model by interacting with this interface, which will trigger the request that will move to the orchestrator. As you can see, there are three pathways from the model inference to the orchestrator: the forward API, API for batch inference, and API for stream inference. Each API is used for a unique case. For example, forward API is used when we would like to get an inference on a specific contract. A good example would be a simulation where we choose one contract with a specific parameters and would like to get a prediction or what will happen. For that case, we use forward API. The next API for batch inference, if we would like to get an inference on a big amount of contract at once. So we would like to, for example, filter, we want to get a specific region. All the contract under this region will be used by this API to get an insight for a segment of contracts. And the API for stream inference, a good example for using this API would be the chatbot, where there is a back and forth request between the model and the user. Looking at the next component of this whole platform is the orchestrator. This component is responsible for overseeing virtual machines, environments, and resources dedicated to process the inference job that are coming from the model inference. The orchestrator efficiently generates and executes the inference job queue. Additionally, the orchestrator requests CI/CD, which is a continuous integration and continuous deployment to deploy a specific image that is relevant for the job that came from the model inference. So after the orchestrator provides all the resources to execute the job, the inference job leads to a deployment of a model with a specific environment and suitable instance. After we've received the result, we store this result in the model evaluator. There is an API connecting the orchestrator and the model evaluator to store result. Now the model evaluator component collects this result and inferences a prediction forecast and compares them with the ground truth. Now in machine learning, we have a term called control group. Because if you think about it, if we have a model that gives us prediction, and we as a user will always take an action based on this prediction, after, for example, 5 years, 7 years, how will we know if the model is still accurate? Because the data set and the environment always changing. How will we know that the model is still providing us correct information and correct prediction if we always interfere with the results? So in machine learning, we have a control group, which is a selected group on which we will receive prediction, but we will not take any action. So we can still evaluate the model performance. After that, we store the computed metrics and evaluate the model performance in the model evaluator. In addition to that, the model presents an interface and a dashboard for real-time monitoring of the model performance. If metric for a specific model decline, or let's say underperform, user can transfer this model from CI/CD back to the training camp, as we've talked before, for retraining and real evaluation. And the last component of this infrastructure is the CI/CD component. This component efficiently manages models, creating deployable Docker images by utilizing Docker Compose files with configuration. Now, for those of you who don't know what a Docker image is, on a high level, a Docker image allows us to take this image, put it on an absolutely fresh and new environment, unfold, and allow the model to run flawlessly with all the dependencies, whether it's libraries, etc. Now, the CI/CD also keeps a record of original model and versions. Also, the model maintains a Docker image registry of all the images containing all the pre-trained model, establishing a structured system for the organized management of production-ready images. And again, in case some model underperform, this model allows for redirection of the corresponding image back to the training camp to ensure continuous improvement of the models. I hope this was clear, the architecture. This is mainly it from my side. And back to you, Katarina.
Okay, thank you. So, yeah, you know, Ronja, I called our training camp for our models Quantico training camps. Okay. Well, let's outline business outcomes that come obviously after implementing this or that a model, MaxBill model. Of course, it is related with, they are all related with the current challenges utilities face nowadays. So let me outline a few ones. So first, it's reduced churn rate. Right, because utilities get this ability to prevent customer attrition, to forecast, predict at-risk customers, and provide them, offer them some, I would say, perks or offerings, discounts, etc., to make them stay. Okay. Another outcome is healthier cash flow, a more stable one, reliable cash flow, which contributes to the overall financial well-being of the organization. Reduction of customer debt and revenue protection. Because again, identifying accounts with a high risk of non-payment becomes available for utilities. And of course, regulatory compliance and customer support, increased customer loyalty, better experience in general. Okay, so here's on this slide, you see we won't dive deep into the whole MaxBill solution because it's huge. There are a lot of things to say, to describe. It's just a little glimpse into how our product looks like. It consists of 8 modules, each enhanced with AI and ML capabilities. So, and our ML modules come as standalone solutions. Not a part of the main solution, but see here you can see like how the whole product and solution looks like. Okay, so guys, I know you have questions, and we will gladly answer them with Ronnie. Okay, so the first one. Can we run that risk prediction on a specific segment of the data? Ronnie, can you answer this question, please?
Yes. It's a good point because as we've seen, there is the possibility to run a prediction on a specific contract and also get a simulation on a specific contract. But it really makes sense for companies to choose a specific segment and run this depth prediction on this segment. So for example, if we have a segment that, for example, related to a specific location, for example, Prague, we can choose by filter that we would like to get a prediction on all contracts that are located in Prague, for example, and receive a prediction based on it. The answer is yes. We can choose by filters a segment or a chunk of contract we would like to get a prediction on and receive results. Yes.
Okay, thank you. Can outcome of what if simulation be provided to CSR automatically?
Mm-hmm. Yes, it is possible, as the machine learning platform is easily integrated with MaxBill itself. So, for example, if a CSR receives a call from an end customer, on the CRM system, the CSR usually have information such as personal information of this customer, where he is located, address, billing address, etc. Now, because of the easy integration, we can also show on the screen, additionally to all the information of the customer, results from machine learning models. So for example, the CSR, additionally to all the personal information, can also see if this customer is under the risk of churning to another company, is the customer is in the risk of debt. And when the CSR visually sees this prediction in insights in front of him, the CSR can take more based decision and more correct decision. and understand which actions you should take with this specific customer.
The next one is what is the process of model adaptation to our billing and customer data?
So if there is a customer with his own billing and CRM system, of course, and it's okay that the customer have different structure of data. So the main adaptation would be a review of the data of the customer requesting the adapting of a specific model. And we have the tools to make this adaptation, such as the training camp and the model extract transformer, when we analyze the data and train the model based on the incoming data. And after this process of adaptation for the new dataset of the customer can use the already new adapted model for his use.
Okay, thank you, Ronnie. I see there is no question for right now. So yeah, I just want to remind our dear audience that the recording of the event will be sent out to all the attendees and participants. And also, if you have any questions specific to your business case, please do not hesitate to request a meeting and to learn how we can actually help you. And you have right now the link to our demo request right now in our chat. So please follow the link and to get like specific information for your business case. So I hope it was insightful for you all. Thank you for your attention. And yeah, that's it. Thank you.
Thank you. Thank you for joining.